Last time we spoke about parametric methods, but on the other side of things is nonparametric methods, where instead of trying to estimate the parameters, we try to estimate the function f itself. Now, in order to do that, we want to go through the space of all functions, right? We want a really accurate function. How do we know it's not this random function or that random function or some crazy complicated function? So in general, nonparametric methods need a lot of data, because for the more data you have, the more information you have, the more you can see how well each case and all of this data fits into one specific function. The more data you have, the more easily you can get rid of a lot of functions right off the bat, right? So in general, non-parametric methods, we're trying to estimate the actual function, in which case we would love more and more data to do so, because the space of functions that we want to try is so large, right? We want to try so many functions. So now that we've discussed parametric methods, non-parametric methods, let's talk about the give and take between interpretability and flexibility. So, you're going into data science, you're taking high-level courses in statistics, statistical learning, data science, things like that. Eventually, you'll get into a position or a career in data science, hopefully, in which case you'll be working with data for people or for companies. You're not just randomly fiddling with data, you have some objective, right? And in terms of a career, interpretability is extremely important. When you go to clients and you say, I'm doing this inference for you, I have your data, I want to show you what's important in your data, what variables are important for you. Interpretability is extremely important. You need to be able to say, this variable has a big impact on your dependent variable, right? And so this predictor has a really big impact on your response variable. So the connection between each of your predictor variables and your variable of interest or your dependent variable, that's super important. Interpretability is very important. And so you don't always get that. So the more interpretability you have, in general, there's a little bit of wiggle room here, but it is pretty much a give and take. The more interpretable a model is, the more restrictive a model is, and the less flexible a model is. So linear models are extremely important. They're widely used. And one of the reasons for that is because linear models they're one example of an extremely interpretable model. So you can do a linear model and you can say, this variable, this xi variable, has this direct impact on your response variable. That is overwhelmingly useful, especially in a realistic career situation. Okay. So in general, as interpretability goes down, flexibility goes up. So unfortunately, the more you need to be able to explain a model and the direct impact of each of your xi's on y, it becomes a more flexible model. You want more flexible models so you can get more accurate results, but then your interpretability is almost gone. So for instance, a very flexible model would be a spline, but when you implement a spline model, the direct connection between any given xi and your response y is extremely difficult to interpret. So you can go to a client and you can say, I use an advanced spline, I have a great model, it's extremely accurate, I love the model, everything's perfect about it. And they'll say, okay, so tell me about how this is going to impact my response variable. Tell me how my radio sales will impact, my radio budget will impact sales. Well, in that case, you might say, actually, I don't really know. I can't really interpret the results very well. I can just tell you I found a really good model, right? My estimate for f when I use a spline is really good, but I can't really tell you much about the data. Well, that's not very useful in a data science career, right? So this play between how well you can interpret results and how flexible your model is to get super accurate, custom models, this play is extremely important. And as we go on, we'll see the benefits of things like a linear model, again, very interpretable, but it makes a lot of assumptions about your data, often ones that are, even with a little bit of intuition, are incorrect. But it's a strong assumption because you can go to a client and you can say, you know, this is the impact xi is having on y. So to give and take, an important concept to know. Least squares, which we talked about last time, is here. It's very low on the flexibility, but very high on the interpretability. Whereas, so Bohr vector machines, for instance, not very interpretable, but extremely flexible. Okay, and we'll learn, throughout this course, we'll learn a bunch of models, and they'll all sit somewhere on this graph of interpretability versus flexibility.